This is worksheet 1_1 part 2. I'm going to go over how to use the zero product property and factoring to solve a quadratic equation. All of these are quadratic equations, but some of them are already factored, A, B, and C, and some of them still need to be factored. When the question is already factored, that makes it really easy for you because the zero product property says that if any two things multiply to 0, then either this has to be 0 or that has to be 0. So you take each factor and you set it equal to 0 and solve. And that is how you would solve this quadratic equation. You would subtract 13 from each side. You would add 7. And these both work, and you can try them. If you plug in negative 13 into this equation in both places, this will become 0. So it doesn't even matter what this becomes, because when you multiply anything by 0, you get 0. And then you can try 7. If you plug 7 in here, this becomes 0. 0 times anything is 0. So it has to work. So let's try the same thing here. You set each factor equal to 0 and solve. You would subtract 3, divide by 2, so you get negative 3/2. And by the same process, you get 7/3. Same thing here. Either x must be 0, and that's already solved, or x minus 3 must be 0, and so these are your two answers, and you can always try them and be sure that they work. This, you're never going to be able to get x alone no matter how hard you try, so the only way to do this is to factor. The thing that's in common with both of these is an x. So if you take out an x, and then you do the distributive property in reverse, x times what is x squared? That's x. X times what is negative 5x? That's negative 5. Do you see how these are equivalent? If I were to distribute this, x times x is x squared, x times negative 5 is negative x. These are equivalent. Now this problem looks just like this. So the answers are 0 and 5. Here. Now, there's lots of different ways to factor this, but we definitely do need to factor it if we're going to solve it. There's no other way to get x alone. No other way to do it. But how you factor, there's lots of different ways. I'm going to show you, you can use diamonds and rectangles for each of these. You could do factor by grouping. I saw a lot of great different techniques in class today. I'm going to show you how I would like you to get to do them, which is just the most direct, fast way, and it's basically just doing FOIL in reverse. So here's how you do that, and then we can go straight to the answers on both of these. We'll do both of these the same way. Okay, so these two terms need to multiply to x squared. There's only one possibility for that. It's x and x. So you can see how it's already starting to look like this problem in part A. X and x, right? X times x is x squared. So the first term is taken care of. Then we look at the last term. So this is the first term. This is the last term. What multiplies to negative 35? You can do, there's, let's see, 7 times 5, I think, is the only, or 35 times 1. But at this point, to help you figure that out, you can do a diamond if you need to. But what multiplies to negative 35 and adds to negative 2? So you just guess and check until you figure out what those are. So 7 and 5 might come to mind, and you have to make sure the signs are right. So negative 7 and 5. So those, I'm going to put those here. And those do multiply to negative 35. So that works, but I need to check that the inner and the outer add to negative 2x. So if I multiply these together, if I were to do the distributive property, I would get negative 7x. And if I were to do the last terms in the distributive property, x times 5 is 5x. And if I add those up, indeed I get negative 2x when I combine like terms, and that's this term. So this is equivalent to that, and I know I did it correctly, and now I can just solve, and that's 7 and multiplies to negative 5? Well, 5 and 1, maybe negative 5 and positive 1. Let's try that. So now we're going to do the whole distributive property and see if we got it right. So 3x times x is 3x squared. So far so good. We multiply the last terms together. Negative 5 times 1 is minus 5. Of course that works. Now we have to multiply the inner. Negative 5 times x is negative 5x. And the outer is 3x times 1, which is positive 3x. And we're going to add those, since those are like terms. I'm going to add those together, and you get negative 2x. And it doesn't work, right? It doesn't add to 14. So what we can do is we just switch the signs and see if that will work. So we're going to back up here and get rid of that. So we're going to try positive 5 and negative 1 instead. Let's see if that works. So now the inner terms multiply to 5x. The outer terms multiply to negative 3x. Okay, that still does not add to 14. So now we're going to switch the position of the 5 and the 1, because we will get it. So we're going to put negative 5 and positive 1 here. So you just have to be patient. So now you get 1x and negative 15x. And that is not quite going to add up to positive 14, but we're so close. So we're just going to switch the signs. And we should have it. So negative 1x and 15x, and indeed that adds to 14x, which is this term. So we know we factored it correctly. So then we use the zero product property. Either 3x minus 1 equals 0, or x plus 5 equals 0. Solving for x is 1/3